Hi everyone! In this video we are going to look at the difference between transferring a solution and diluting a solution, and how that may or may not affect the concentration of the solution. The concept of concentration is likely familiar to you. You have made juice before, I'm sure. Let's say a cranberry juice, that's that deep red color. A dark color is often characteristic of more concentrated solutions. If you were to add more water to that sample, it would become lighter in color and be more dilute, less concentrated. On the other hand, if we take some of that cranberry juice that we prepared and pour it into a glass, the concentration hasn't changed from what it was in the original pitcher. So that's a transfer, simply pouring a solution from one container to another. The concentration does not change as long as nothing else is added to it. Dilutions are often carried out by adding more solvent. Remember that solvent is the component of the mixture that's present in excess of the solute. So when we add more solvent, the concentration of solute will decrease. So keep in mind that concentration is expressed as a molarity, which is equal to some number of moles per volume in liters. So if we add more solvent, my volume is going to increase, and as that number in the denominator increases, the molarity, or the concentration, should decrease. Mathematically, that would work out. And to calculate the new concentration after dilution, it's pretty simple. So the number of moles, N, in a sample is going to be equal to the number of moles in your diluted solution. So this is the original, and the second solution is the diluted solution. If we don't change the amount of solute present, the number of moles of solute are equal in each of these samples. Okay? So we can derive a formula that will allow us to calculate the concentration after the dilution. And we could even calculate the original concentration if we were, say, working backwards in a problem. So concentration is equal to moles per liter. I'm going to rewrite this as N over V. So N is the variable often used for moles, V for volume. So if my number of moles is equal to M times V, I can combine these two equations to get M1 V1 equals M2 V2. And this is the dilution formula. You may have seen it before. You can use C rather than M here. So C for concentration, M for molarity. It doesn't have to be in molarity. It can be in any concentration unit. So even a mass per volume like we saw before, or any of those mole or mass fractions, we could do this formula as well, as long as your units are consistent on both sides. So we can work with any volume unit, any concentration unit here. And the equations here, N1 equals M1 times V1, comes from rearranging this equation, right? If I solve for N, I get M times V. Okay, so my original solution, the concentration and the volume, and then my diluted solution, the new concentration and the new total volume. Okay? So let's look at an example problem using this dilution formula. So here's the problem. If we have 10 mils of a 2.25 molar sodium phosphate solution and dilute it to 40 milliliters, how many moles of sodium ions are contained in 20 mils of the dilute solution? Let's draw out pictorially what is happening throughout this problem. So if we have a solution here, we have 10 mils, and it's 2.25 molar sodium phosphate, Na3PO4. And this is my concentration. Okay? And the volume, like we said, is 10 mils. We are diluting that to 40 mils. So now I have more solution in my beaker the volume is 40 milliliters, and my new concentration is unknown here. Okay, and then I transfer some of that to a new container. I transferred 20 mils of that. And the concentration here, let's call this M3, if this is M2 and M1. This M3, because it's just a transfer, the concentration here is equal to the concentration back here at M2. Okay? And we want to know the number of moles of sodium cations here. All right? So this is going to require several steps to solve this problem. First, we need to know the concentration here. And using that, we can find the number of moles in this 20 ml sample of the diluted solution. So I would use the M1 V1 equals M2 V2 to solve for the concentration after dilution. So 2.25 molar is this concentration of my sodium phosphate. The volume is 10 milliliters. My final concentration is unknown, and my final volume is 40 mils. So your concentration units are moles per liter here, and like I said, we can work with any concentration units as long as they're the same on both sides, and any volume units as long as they're the same on both sides, such that they cancel. So we're going to divide both sides by 40 milliliters, so you'll see my volume unit cancel out, and we'll be left with a concentration of molarity. The math here works out to be 0.563 molar sodium phosphate. So thinking about where we're going, that's the concentration of sodium phosphate in my diluted solution. Of course, it's less than what we started with, that makes sense. And then because we're just transferring it, the concentration here is the same. So I know the concentration of this sample now, which is what I want to know, how many moles of sodium are in here. So because I want to know moles of sodium, and right now we have it with respect to moles of sodium phosphate, I'm going to go ahead and convert this to sodium phosphate by accounting for ion concentration. So this is an ionic compound. It would dissociate into 3 Na ions and 1 phosphate ion. So for every 1 mole of sodium phosphate, I have 3 moles of sodium cations. So I'm going to cancel that out, and I will essentially have a concentration that is 3 times larger than that. And that concentration is 1.69 molar sodium cations. All right, now we have a concentration of sodium cations, and we want to know moles of sodium cations. And we know that the concentration in moles per liter is equal to moles per volume. So by rearranging this equation, we know that moles are equal to the concentration times the volume. And we have a concentration, 1.69 molar Na plus, multiplied by the volume. And we do need to pay attention to our units here. So molarity is moles per liter. And I will need to have my volume in liters here. So we'll convert to liters, 0.020 liters. That way my volume units canceled, I'm left with moles of sodium cation. This math works out to be 0.033 moles of sodium cations. So we have that many moles of sodium cations in this 20 ml sample of solution. Okay? So this required us to fold together the concepts of dilution and transfer and work out the answer to what was asked. Now, I could have solved this a different way. So it would have been fine to start with this concentration and first calculate the sodium ion concentration and then work through these steps. So we could rearrange the order that we did these, and you would get the same answer. So if you didn't do it exactly this way, but you got the same answer, more than likely you are good to go. So give a couple more of these types of problems a try as you're practicing, and let me know if you have any questions. Thank you for watching.